Today's video is going to be on Venn diagrams and two-way tables. So our learning goals for today is by the end of the lesson you'll be able to construct and interpret two-way tables, you'll be able to construct and interpret Venn diagrams, and you'll be able to use two-way tables to calculate probabilities. Okay, so two-way tables. So two-way tables list the number of outcomes or people in different categories, with the final row and column being the total of other entries in that row of column. So what? Okay, I'll show you below. So for instance, if we surveyed students in Year 8 on whether they liked maths or whether they liked English. So we have a few outcomes. So if they liked maths, they'll go in this column. If they do not like math, they'll go in this column. But it's not just about math, it's also about English. So if they like English, they'll go in this row. And if they do not like English, they'll go in this row. So for instance, the 28 students here, if you follow this down, they like math. If you follow this across, they also like English. So these 28 like both. If we follow that, let's go this one, these 5. So these ones, they like math, they're in that column, but if we go across this row, they do not like English. So these 5 like math, don't like English. And then our total at the bottom, 33, it's our total for liking maths, because if we follow that down, it's just our total for liking maths. So 33 in total. The 33 here, so they fall in the do not like maths column, but they like English row. So 33 like English, don't like maths. And this total is the total who like English, because it's only in that row. So 61 of them like English. Okay, we'll go down here. These 34, they're in the do not like maths column and do not like English column. Unlucky for them. And if we keep going down, this 67 is 67 total who do not like maths. Obviously, they didn't survey you guys. And this total here, 39, that's the 39 total who do not like English. And our 100 here is actually our grand total. So if we do 61 plus 39, we will get 100. Or if we do 33 plus 67, we will also get 100. So that shows the total number of students who were surveyed. Okay, so we can use these two-way tables to find out our probabilities. So for instance, what's the probability that a student likes maths? Okay, so this is our like maths column. So 28 like math and like English, and 5 like maths and do not like English. So that's a total of 33. So 33 students like math. So 33, which is our number of desired outcomes, over our total, which is 100. So 33 of 100 students like math. Can we simplify that any further? Nope, that's all we can do. Okay, so our probability, actually I'm going to clear this. Okay, so that was 33 over 100, 33 over 100. So our probability that they like math and English. So they like math, that's this column. They like English, that's that row. They intersect here with this 28. So that is 28 over 100. Can we simplify that further? Probably. So 28 divided by 4. So that's 7 over 25. So 7 out of 25, 7 over 25 like maths and English. So the probability that a student only likes English. Okay, so likes English is going to be our top row there, but they don't like maths. So we're going to follow it down to the do not like maths, and that leaves us with 33. So 33 students like only English. So 33 over 100 would be our probability there. So that's how we can use these two-way tables to calculate probabilities. I'm not sure if I've already said it, but I'll just classify. I'm getting the 100 here because that's the total number of students that were surveyed. Okay, so a Venn diagram. A Venn diagram is just a pictorial representation of a two-way table without the rows or the columns. The total rows or columns. So you can see here we have a circle in red which shows math, and we've labelled it maths. A circle in blue which shows English, and we've labelled it English. So you can see here this number 5 is just in the math circle, and that shows the students that only like math. We've got 33 here which is just in the English circle, so those are the students that just like English. We've got 28 that are overlapping, so that 28 is in both the math and the English circle, and they're the students that like both math and English. And then we've got these 34 sad ones over here in the corner, and they're not in either circle, and that's because they don't like either maths or English. So they're going to have a bad time at school. Okay, let's do a worked example. So a survey is conducted of 50 people asking who likes coffee and who likes tea. So it's found that 20 people liked both, so they like tea and coffee. 15 people liked coffee but not tea. 10 people liked tea but not coffee. Okay, so how many people liked neither tea nor coffee? Okay, so if we had a total of 50, okay, so we had 20 liked both, 15 liked coffee but not tea, and 10 liked tea but not coffee. That equals a total of 20, 35, 45. So 45 obviously likes something. So we'll do 50, take 45, leaves us with 5. So that means 5 people don't like either tea or coffee. I would be one of those 5. So we go 5 people. So B asks us to represent our findings in a Venn diagram. Okay, I'm going to clear the screen and I'll rewrite that in 5. Okay, so a Venn diagram. The first thing we're going to do for our Venn diagram is we're going to draw our box, which is going to represent all of our people surveyed, which was our 50. I'm probably going to regret making that so small. Okay, so I'm going to use, what colour? We'll use green for tea. And we'll draw a circle to represent, these are the people who'd like tea. That is a terrible circle, but use your imagination. And we use red for coffee. I know it seems energetic or something. And people who like coffee. So remember, we're going to overlap these because there are some people who like both. I'm going to overlap them. Now we fill it in. Okay, so let's read through it. So we survey 50 people total. 20 people liked both. So that 20 is going to go in the middle. So 20 people like both tea and coffee. So I'm going to write that answer in the middle there. Okay, so 15 people liked coffee but not tea. So they're going to fall in this circle here where it's 15 here, just in the coffee part, not in the tea part. And we had 10 people who like tea but not coffee. So they're going to fall and they're outside there. And then we can't forget our 5 people who don't like tea or coffee. So that's what we would do there. So how many people surveyed liked tea? Okay, so what we're going to do there is we're going to find out the total number who liked tea. So we had 10 people, we can see there, 10 people liked tea, but we also had 20 people who liked tea and coffee. So we had another 20 who would like tea as well. So that would give us a total of 30 people. So therefore 30 people like both. 30 people surveyed liked tea. So 30 out of that 50 liked tea. Okay. Oh no, my Venn diagram's gone. So I might have to redraw that because I've changed slides. I'll be really quick. Draw up our box. Draw out a circle for tea. Oh, that's a better circle. Draw our circle for coffee. Ugh. Coffee. Okay, so we had 15 people liked coffee and not tea. We had 10 people like tea and not coffee. 20 people in the middle who like both. That's a 20, not a, yep. And we had 5 who liked neither. Okay, so how many people like both coffee and tea? Obviously that's that overlap in the middle, so there's 20 people in the middle there. How many people like coffee or tea or both? Okay, so we're going to add all those together. So how many people like coffee? So 15 people liked coffee. We had 10 people who liked tea and 20 people who liked both. So we're just going to add all of those together. So 15 plus 10 is 25 plus 20 is 45 people. Okay, and that last thing is to represent the survey findings in a two-way table. Okay, so again, my lack of ruler is the bane of my existence. So we're going to draw up some columns and rows. So we'll have like coffee, don't like coffee, coffee, and then obviously our totals. We can't forget our totals. So that'll be our first. And then on this side, we're going to have, like tea, don't like tea, tea, that's an A, not an N, don't like tea, and remember our total. Now, we know that 50 people were surveyed, so straight away I'm going to put 50 there because we know there were 50 surveyed. Okay, so we found that 20 people liked both, so they're going to fall in the like coffee column and the like tea row. Now this one here is don't like coffee but like tea. How many people don't like coffee but they do like tea? Was 10. People who like coffee but don't like tea was 15, and people who don't like either was 5. So then we can draw in our totals. So start this one here, 20 plus 10 were our total people who like tea. So 20 people plus 10 people is 30 people total like tea. This one below it is going to be the total who don't like tea. So 15 plus 5 is 20. If we add those together, we do get 50, which is good. Now we'll do our columns. The total amount who like coffee is 20 plus 15, which is 35. And our total amount who don't like coffee, which is 10 plus 5, which is 15. So just to show you, I'm going to draw some arrows, probably make this really messy, but just show you how our two-way table and our Venn diagram correspond. So this 20 here, the people who like tea and like coffee, that's in the middle of the Venn diagram there. Okay, these 10 who like tea but don't like coffee, that's the 10 here. These 15 who like coffee but don't like tea, that's that 15 there. And lucky last, these 5 who don't like tea or don't like coffee comes from here. So hopefully you can see how those numbers correspond in a two-way table. Okay, so another example, consider the two-way table below showing the eating and sleeping preferences of different animals in the zoo. So we've got eats meat and doesn't eat meat, and sleeps during the day and only sleeps at night. And obviously the total there was 100 animals. So for a random animal, find the probability that it sleeps only at night. Okay, so our probability is the number of times when that occurs. So only sleeps at night. So that would be our total for this row here. This is our only sleeps at night, and our total number there would be 68. So it'd be 68 out of the total number surveyed, which was 100. And then we can simplify that fraction. So 68, what are we dividing that by? 4. So that's 17 over 25. Okay, our next one is the probability that it eats meat or sleeps during the day or both. Okay, so we're trying to find out, I might change color pen so it's not confusing, the probability that it eats meat. So these 20 animals eat meat and sleep during the day, 40 animals eat meat and sleep only at night, or both. Sleeps during the day, and also these ones sleep during the day. Okay, sorry, that was probably a confusing way to explain that. So we're looking at animals who eat meat or sleep during the day or both. Okay, so this circle here and this circle here represent all animals that eat meat, and this circle here, and again this one, represent animals that sleep during the day. So those are the three sets of data that correspond to what we're being asked. So the probability that it eats meat or sleeps during the day or both is going to be 20 plus 12 plus 40 over 100. So 20 plus 12 plus 40, let's go 72. Yep, 72 over 100. And then we can simplify that. I don't know what we can divide it by. Let's go 4 maybe? Nope, something bigger than that. 6. 12. Okay. No. Anyway, whatever. We'll simplify that. Whatever it can be simplified by. I think it is 4 actually. That would make it 25. And 72 divided by 4 is 18. I think that was as small as we can go. Okay. So B, if an animal is selected at random and it eats meat, what is the probability that it sleeps during the day? Okay, I'm going to clear this so that we can have a clear two-way table. Okay, if an animal is selected at random and it eats meat, okay, so that means we're only looking at animals that eat meat. So there's 60 of them that eat meat. What is the probability that it sleeps during the day? So how many of the animals that eat meat also sleep during the day? So there's 20 of the 60 that only sleep during the day. We can simplify that. 1/3. So the probability that an animal that eats meat also sleeps during the day is 1/3. Okay, so what is the probability that an animal that sleeps during the day does not eat meat? Okay, so we're going to look at all the total number that sleep during the day, which is 32, so it's over 32. What is the probability an animal that sleeps during the day does not eat meat? And there's 12 of the 32 that don't eat meat. So we can divide that by 2. Nope, 4. Let's try again. There we go, 3/8. Okay, so 3/8 of the animals that sleep during the day don't eat meat. Hopefully that was clear how we can use these two-way tables to kind of work out probabilities. If you need any help, make sure you come and see me in class.